The future can feel impossible, but we build it together, one beat at a time. Technology helps us do impossible things, like detect cancer cells earlier than ever before.
I love you so much.
Help students learn about the world, and map brand new ones. Arm's technology is helping defy expectations, and it's leading the way to keep us all safe. Arm is in billions of devices all over the world, unleashing the power of AI, helping us do the impossible. Because impossible is technology waiting to happen.
Please welcome Chris Bergey. 现在让我们热烈欢迎 Chris Bergey.
Yeah. Thanks, David. Ni hao. Well, it is absolutely an honor to be back here at COMPUTEX, be back here in Taipei. And what an exciting time it is as we all have this new role to play in the age of AI. And in many ways, this is not just another year or just not another COMPUTEX. This is it. We're at the doorstep of likely the most important moment in the history of technology. This is bigger than the internet. This is bigger than smartphones. And as David mentioned, for over 40 years, COMPUTEX has been a launch pad for many great initiatives and industry activities. But this year's different. Why? AI is no longer an idea. It's a force. We need to dream boldly, design fearlessly, to deliver the breakthroughs to transform billions of people's lives. And the best part, we don't need to do this alone. We can all do this together as part of the Arm ecosystem. We're quickly seeing AI reshape every industry. Workloads are becoming more diverse, and the compute demands are growing tremendously. This finding a balance between performance and power has never been more crucial. And of course, we've got software becoming more complex and expensive. This requires a tight connection between hardware and software, a platform built for this moment. That's where Arm comes in. We've had 3 decades of performance, power efficiency, creating the world's largest compute footprint with a front row seat of what's coming. Together, we can evolve the Arm compute platform for AI from cloud to edge. This is a shift unlike anything we've seen, for sure in my 25+ years of doing this. It's no longer about what AI might do. It's about what AI is doing. Every product team is now an AI team. Every hardware decision is now an AI decision. The way we build has changed. The way we will scale is also changing. Now is the time to build for what's next. Models are not just evolving, they're accelerating. In the last 18 months, we've seen over 150 new foundational models, each of them with greater than 90% accuracy. We've gone through a shift to multimodal. And while there's a few building blocks stabilizing, the pace of innovation is mind-blowing. Even for people like you and I that are doing this every day, it's incredible this pace we're on. We've all used AI, but if we just think about how AI has evolved from last year's COMPUTEX to this year's COMPUTEX, it is amazing how quickly things are going. I've gotten a chance to talk to many of you in the audience at different events over the last 12 months, and we talked about AI and what were some of our big use cases. And there was this theme of a concern that the hype was kind of outpacing potentially the reality. Fast forward to today, I've got a totally different outlook. Almost every week, I am amazed about how someone inside of Arm, some team is using our enterprise ChatGPT. I'm amazed at how my children, as young adults, are using ChatGPT to change the way they approach life, the way they approach their education, the way they approach their challenges. This really is an amazing moment. On-device AI is happening. AI initially lived in the cloud, but the shift to the edge is happening. And it's not just phones. It's glasses, cars, everything in between. 6 months ago, AI assistants largely lived in the cloud. Today, you see AI assistants being developed for the edge first, unlocking new experiences not possible before. You don't need to imagine the future, you can imagine it. Just like my ARM-powered Ray-Ban glasses. Whoops, sorry. Activated it there. These Ray-Ban glasses are not just for early adopters like you and I. This is now the top-selling product at more than 60 Ray-Ban stores in Europe. And you can see what AI can start doing as we interact with the real world. This frictionless interaction is changing what's possible. We've seen the emergence of AI agents, and we see physical AI emerging. Two promising use cases I'll highlight today: coding and customer support. The left is Cursor, an AI-powered code editor. On the right, Ada, a computer support system that responds with no humans in the loop. Both of these companies have gone from 0 to 100 million in revenue in less than 18 months, both with less than 100 employees. But we see new examples every week showing up of what agentic AI can do for us. And then you have the emergence of physical AI, not just thinking, but doing. AIs that can sense, interact, and respond to the physical world. We're seeing this play out in areas like manufacturing and logistics. What is the common thread? AI is everywhere, from coding assistants to glasses to autonomous machines. AI is happening across every form and every environment. But we're just getting started. And what's the challenge? This all requires a massive amount of computing, not just in the cloud, but everywhere AI runs. Next frontier isn't just about models. It's about where these models will run. In many ways, Taiwan has a super exciting role to play in the world of AI. It really is, in many ways, the backbone of AI. From motherboards to SoCs to packaging that's so important in AI, as well as manufacturing. From design, hardware, Taiwan really is at the epicenter of AI. And it's only possible because so many of you in this room and what you're doing. But the reality is that AI will require even more partnership and more ambition than ever before. At Arm, we believe it's our responsibility to help you get AI to the market quickly. Everyone and everything is connected. Performance, power, software, time to market. It's all part of one problem. We believe that the future of AI rests on three foundational elements: ubiquitous platform, world-leading performance per watt, and a powerful developer ecosystem. These are the building blocks of AI, and this is at the heart of what Arm does. AI is requiring more power and is memory hungry in ways that we haven't seen previously in computing. We've moved from room-sized mainstreams to amazing computers that are in our pockets. Then we saw how the cloud computing evolved servers, and now we're building for AI, from cloud to edge. Let's talk about this future. It starts with a platform. Arm is way more than an architecture. We are a platform. The mission is simple: give you everything you need to get to market fast and stay ahead. From the hardware at the bottom of the stack, all the way through the software on top of it. AI is transforming every market, from data center, smartphones, wearables. And it's not just cores, it's an entire system on a unified platform. We need to move faster, scale smartly, and build AI and bring to life from cloud to edge. Together, what we've accomplished as an ecosystem has been truly unmatched. This is the most ubiquitous computing platform in history, with over 310 billion ARM-based chips shipped to date. No other platform touches more devices, more developers, more users. But scale alone isn't enough, because in AI, compute needs to happen everywhere, and it needs to be efficient everywhere. That's where the true opportunity comes into focus. AI is driving exponential software capabilities and use cases. AI software is hard. One of my favorite anecdotes is how I get to talk to a lot of very interesting AI startup companies. And the story is very, very similar. They start a company, have a great idea. They start with 50 hardware engineers and 50 software engineers. I come back and get a chance to visit them 12 months, 18 months into their journey. They still have their 50 hardware engineers, and now they have 250 software engineers. This is why Arm is making such big investments around our developer ecosystem. And what a developer ecosystem it is. The software running on the Arm platform at this point in time has more than 22 million developers running software on Arm for Arm. We've created the world's largest computing footprint. And it's a virtuous cycle. More hardware creates more software. More software being written creates a flywheel for even more hardware. Arm's been around for over 30 years, and we've been writing optimized software for our platform with so many of you. Let's talk about how this software investment is evolving in the age of AI. So last year, on this very stage, we announced our Kleidi libraries. These libraries plugged into open source frameworks. They provided instant benefits on so many of these billions of ARM platforms, ensuring that software would be able to take advantage of our V9 architecture and AI performance for developers. And what a difference a year makes. Kleidi has now been integrated with the leading AI frameworks, whether that be Onyx from Microsoft, LightRT from Google, Executorch from Meta, or Tencent Oyan, enabling developers to accelerate their AI workloads across billions of devices. And now, we're proud to show that Kleidi is able to run from cloud to edge. So whether you're building a mobile app, a data center application, AI-enabled vehicles, or autonomous machines, instant performance benefits are available via Kleidi. And we've had over 8 billion installs to date. What an amazing accomplishment. Performance per watt is at the backbone of everything that Arm does. It's been our obsession for almost 40 years of existence. And it's not just what we do, it's what we think about. And while many of you know that Arm has a significant presence in the edge and in handsets, Arm has been doing a lot more than just edge computing. Let's talk about where Arm has gotten to in the data center. AWS, at their reInvent event last fall, showed the following statistics. And you could see how the ARM-powered AWS Graviton platform is driving the most significant portion of Amazon's services. Now, you might say, okay, that's great, Chris, but that's Amazon's own workloads. Well, guess what? Amazon's customers, over 90% of 1,000 largest EC2 customers are also running on Graviton chips. That's impressive. But what's even more impressive is what they shared next. And that's over the last 2 years, over 50% of the new CPU capacity that AWS deployed was ARM-based. Let me just say that again. Over 50% of the compute capacity that AWS aided in the last 2 years was based on Arm's AWS Graviton CPU. Now that's impressive. But it goes way beyond Amazon. Every major cloud provider has an Arm platform, whether that's Microsoft's Cobalt, Google's Axion, Oracle's relationship with Ampere, and Alibaba's Yatin platform. But this is not an accident. Let's talk about why. They build servers to run first-party workloads. But then they quickly are able to optimize their third-party workloads to run on Arm as well, providing up to 40% more power efficiency. And let's talk about power. The stakes are rising very, very fast. AI-first data centers are more power hungry than ever before. And over 50% of a data center's power goes to the racks and the semiconductors that sit on those racks. Just in Taiwan alone, there's an expected 8x increase in data center usage. We're talking about going from megawatts to gigawatts. And you don't scale just by adding more racks. You scale by getting more performance, greater performance density. Compute efficiency absolutely matters. The simple truth is that we can talk about how wonderful AI is going to be and all the opportunity, but if we don't solve for efficiency, AI won't scale. So let's talk about what else is not working. Yesterday's legacy architectures. These architectures were not built for AI. They were built for traditional workloads, web servers, basic computing, not the massive throughput that AI demands. The real bottleneck is the CPU we need greater CPU density, greater I/O density to keep these GPUs and other accelerators fed. It's not just suboptimal, it's unsustainable. And you can follow here with the NVIDIA journey that they've been on as a leader in AI. And you see in pre-2020, NVIDIA leveraged standardized commodity servers. In 2020, they introduced their DGX customized servers. But that wasn't enough. So actually, in GTC 2021, when we were all watching Jensen's keynote from his kitchen while we were working from home, he talked about what modern AI infrastructure looks like. Leveraging Arm Neoverse Grace and creating a balanced system with tight coupling of CPU, GPU, and DPU. 25x what was possible before. This is how you scale. And you can see it today with NVIDIA moving to Grace Blackwell and their Vera Rubin AI cluster, all built upon tight coupled AI computing with GPU compute. And as Jensen says, AI factories are the future, and Arm is at the core of this. But again, it's not just NVIDIA. You can see our clear trend of custom silicon being co-designed for AI, whether that be AWS, whether that be Google, whether that be Microsoft. The only way to meet the performance, efficiency, and scalability demands of AI. What's powering all this? Arm. And this is why we can say, by the end of this year, we believe that 50% of new devices shipped to hyperscalers will be ARM-based. That's pretty cool. But no one just builds models for the sake of building models. And that's where AI inference comes in. So if you look at the computing requirements to build one of these foundation models, in this year, it's taking about 10 to the 25th or 10 to the 26th flops. That is an incredible amount of compute. But the reality is that unless you're selling training silicon, memory, or maybe power to data centers, the intelligent monetization happens through inference, not training. Now, if we look at what kind of computing requirements are there for one of those inference workloads, so let's talk about a large language model chout output. You're talking about something between 10 to the 14th or 10 to the 15th flops, okay? Now, that's a delta of 10 to the 11th. 10 to the 11th is a very big number, and let me give you a little bit of perspective here. The number of worldwide searches that happen any day on the internet is approximately 10 to the 10th. So it basically says that it will take you 10 days of using the model for every search that's done on the internet to be the equivalent amount of compute that it took to train that model. And I think that's important to give you an idea of the kind of scale that we need to achieve in computing and to unlock the value of all this model training, how AI will need to run everywhere. The power performance per watt is critical in so many of the devices that we use today. And ARM-powered smartphones are a clear example. But we've been working for years with OEMs and platform providers to extend this world-class efficiency. And when you think about what you actually expect from a industry-leading PC today, it's very similar to what you expect from your smartphone. You expect all-day battery life, you expect a fanless design, you want amazing multimedia for video conferencing and the like, and then you want AI. We see this evolution happening, and this is where Arm and our partners have such an amazing opportunity. Today, the ecosystem is powering innovation across every major platform, from iOS to Windows on Arm, Chrome OS, and Android. Longer battery life, lower thermals, smarter performance. The PCs are being designed to be ready for the AI workloads of tomorrow, delivered with the power efficiency Arm is known for. More than 40% of the PCs and tablets that ship this year will be Arm-based. And this is not just about growth. This is about what it's unlocking. From entry-level to flagship, we're democratizing AI by bringing it to more places than ever before. And I wanted to talk about a little bit how we're driving this to the future of PCs. So last year, again on this stage, we introduced our CSS for client. We talked about double-digit performance gains on CPU. We talked about industry-leading immersive graphics and power efficiency. We also talked about scalability and how these solutions were scalable from mobile to PCs and beyond. Let's look at what some of our incredible partners have done with this technology. DGX Spark. This platform, 20 Arm CPUs, latest V9 CPUs, paired with a GPU that provides a petaflop of AI computing on your desk. An incredible amount of computing that was only previously available in a data center. Let's also look at what MediaTek's done with their companion chipset, scaling down that architecture to power next-generation Chromebooks with tremendously efficient AI subsystems. You can also see what MediaTek's been able to do in the mobile space, acknowledged by leading reviewers that Arm's technology is market-leading. And of course, we're not stopping. Last year, we introduced Arm's Accuracy Super Resolution. This provides algorithms and upscaling only previously possible on the latest consoles. Here you can see Mori running at 540p being upscaled to 1080p. Better graphics, better performance, all in a power envelope of what you can put in your hand. And this plugs into the most popular game engines from Unity and Unreal. Just a few years ago, we introduced Arm V9. Since then, we've had amazing handsets and AI PCs powered from chips from companies like MediaTek. Today, I'm going to give you a sneak peek of our next CPU, Travis. The power performance delivered through new levels of IPC. We already have the highest level of IPC of anyone in the Arm ecosystem. We are putting on another double-digit IPC gain in performance. And additionally, we have our scalable matrix extensions, SME. This allows acceleration in the CPU of AI workloads, giving developers a common instruction set, better performance, and seamless migration across ecosystems, including support for Kleidi AI libraries. With Travis, we have double-digit IPC gains, and the addition of SME provides performance and efficiency for AI and CV workloads. We're going to pair this with our industry-leading GPU. It's truly a mobile gaming beast. Draga, our next-generation GPU, unlocks sustained performance for longer gaming. We're adding more features on top of our already industry-leading ray tracing, and we're creating easier game developer experiences via Vulkan and the Arm Mobile Studio. You'll see more coming later this year. It's an amazing mobile platform to enable more AI capabilities. Truly console-level graphics in the palm of your hand. That's just a small preview of what we see as the future of Edge AI. With Travis, we talked about CPU innovation, more performance, more efficiency, more headroom for AI workloads. With Draga, console-level graphics, smooth gameplay, immersive experiences. Working with you, we can enable the future of AI, scalable from laptop to mobile to workstations. AI truly is everywhere. Arm is everywhere. This connection isn't by accident. Everything we built for decades has prepared us for this moment. Together, we're laying a foundation for AI everywhere. Again, as I mentioned at the top, this is a once-in-a-lifetime opportunity for all of us to imagine, to design, and to deliver next-generation platforms of the future. Thank you for your trust, your relentless drive, and pushing the edge of what's possible. But the future of AI cannot be built alone. It takes an ecosystem, and I'm thrilled to have two key partners joining me on stage. Kevin Deierling, Senior Vice President of Networking, NVIDIA, and Adam King, Vice President and General Manager, Personal Devices Business Unit, MediaTek. Do the fist bump.
There you go.
All right, Adam, Kevin, thanks for joining me.
Great to be here.
Great to see you guys. It's great to be back in Taiwan, right?
Absolutely.
All right. So obviously, NVIDIA, MediaTek are two incredible Arm partners. We have so many. But it's a real pleasure to have you guys up here, two industry experts. Kevin, maybe just start with a little bit your position at NVIDIA, and I got some questions for you.
Super, yeah. So I'm SVP of networking at NVIDIA. I work on some of the products you showed there. So I'm responsible for the Bluefield and the ConnectX, but also get involved with all of our networking. So NVLink, Ethernet switches, Spectrum, and our InfiniBand products. Thanks.
Yeah, and Kevin, you've been at this for quite some time now, and obviously it's been an amazing journey. You know, I talked about what NVIDIA's done, right? And really, I think, kind of reimagining how you optimize compute, right? Looking at the computing requirements, memory bandwidth, acceleration, and how do you put together systems? And obviously, with kind of Grace Hopper and then moving to Grace Blackwell, I mean, it's been a pretty amazing transformation in my view. Where do you think we go from here? What's the next wave of innovation here to come?
Yeah, so I think you pointed out that if we look at training versus inference, 2025 is the year of inference. And it's important because those foundational models cost a ton of money to train, but they actually cost money. They're on the expense side of your income.
Well, not for you guys, but everybody else maybe. I think they're creating some revenue for you, Kevin.
But inference is on the revenue side. So we see inference, and people misunderstood inference. They thought it was going to be very simple. They thought it was going to be a single node. Networking wasn't going to be important. None of that is true. It's actually complicated. Inferencing is very heterogeneous. There's lots of different models. People are going to run different types of models. There's all kinds of ways that we can tune those models. Pipeline parallelism, data parallelism, expert parallelism, disaggregated inferencing. And as we move from a place where we're seeing a human ask a question and get a single shot answer, immediate from that foundational trained model, we're moving to agentic workflows where AIs are talking to AIs are talking to AIs. And the thing that makes inferencing hard is that latency matters. Humans are both very slow, but also very impatient. We're slow. Computers make fun of us behind our back, but we're impatient. If you ask a question and it takes seconds to get an answer, we feel uncomfortable. We can jump to something else and start doing. And as we go to these agentic workflows where AIs are calling AIs or calling AIs, that latency compounds. It just adds up, and we can have 100 internal tokens. So I'm curious about your numbers there. I want to go see whether that's agentic or not, or whether it's single shot for inferencing. Inferencing is getting a lot harder. So we see really the evolution here of AI is inferencing this year, but also towards the physical AI that you talked about. And again, latency is critical there, where you have robots operating in factories with humans around them. You need lightning fast response. You know, the speed of light literally starts to matter. We need to start looking at putting that in the edge. You can't bring everything back into a centralized core data center and go back and forth a dozen times. It just doesn't work.
That's super interesting, Kevin. Really insightful. Adam, can you tell our audience here a little bit about your background and your role at MediaTek?
Sure. Hi, everybody. I actually came from, most of my career was at Intel, but I joined MediaTek about 3 years ago. And I'm the general manager for our personal devices business unit, which includes Chromebooks, tablets, smart home devices, gaming devices, and a couple of other things. Definitely on the inference side of the equation.
Thanks, Adam. So with your background in personal computing for quite some time, and MediaTek, I mentioned the Compagno announcement, super exciting what you guys are doing there and taking that forward. I mean, how do you see AI changing how we use devices? Like, and obviously through our partnership, where do you think that can go for the future?
Sure. Well, at the risk of being obvious, we do see AI as the transformational technology that brings a huge step function to improve user experiences, improve existing device categories, as well as really enable some new ones, like those cool wearables that you've got on. What's great about it is that it really lifts all boats. Even existing devices like that 3-year-old laptop that you might have is better today than it was 3 years ago, because now you have access to all these great AI services, because those start in the cloud. But as you mentioned, the workloads want to move to the edge, depending on what workloads they are and depending on what the user requirements are. So we're even more excited about the opportunity to figure out where those workloads should reside. What should be done on the cloud, what should be done on device, and even within the device, what's the compute engine of choice? The CPU, the GPU, the NPU? It really depends on the device and the workload. And so for MediaTek, it's an opportunity to really bring all those ingredients in the right way to the right products, to the right customers. You mentioned the Compagno Ultra. Thanks for the shout out. That's our premium high performance SoC for Chromebooks that we just launched a month ago. Highest performing Chromebook chip on the market. And we brought a ton of inference capabilities to it, 50 TOPS. It's really going to enable a lot of current and future on-device models.
Very cool, very cool. So I shared a little bit in my talk about some of the ways that I've, I guess, thought about AI and how AI's made an impact for me. I'm curious for you guys. Kevin, has there been that like aha moment for you? What has it been?
Yeah, no doubt. I mean, when we looked at AI, here I was working at NVIDIA, but we saw the ChatGPT moment happen as well. And all of a sudden, everybody, you got grandparents and cousins asking you about, oh, you work for NVIDIA, you know, AI is changing the world, and it really is. So we're excited about that. You know, I think the physical AI is coming, and we see that the DGX Spark, you're going to have AI on your desktop. So thank both of you for that. The GB10 is the heart of that platform. You know, we're talking about a petaflop, which is incredible to deliver in a tiny little package. So certainly it's exciting times.
Very cool. How about you, Adam?
You know, I love the DGX Spark example because that's a great example of partnerships, which I think is a key theme in Taiwan. Bringing together two companies that have complementary strengths to create something new and amazing that would have been a lot harder for you know, any one company to do by themselves. And of course, in partnership with Arm. I love your CPUs. They're fantastic. They're getting better and better every year, and they're the best in the industry now. We're using them, of course, in the Companion Ultra to power the high-performance processor.
Thanks, Adam. So let's talk about, we talked about AI, and obviously there's a lot of good things. We talked about power, we talked about challenges. I mean, if there was one industry constraint, technical or commercial, that you could eliminate, not have to worry about it anymore, Kevin, what would that be?
Yeah, you said it, power. You know, the thermal and power constraints are really holding us back. We are advancing the performance per watt. That's the way Jensen measures the performance per dollar and the performance per watt. We're continuously improving that from generation to generation. But at the same time, the actual compute requirements are growing even faster. So we're doing all kinds of things to actually decrease the power. So we have optics to scale these giant data centers out. You have to have optics. We're doing the co-packaged optics. So we're reducing the number of lasers. We're putting the optics right next to the switch chips. And we're also, obviously, with our NVLink 72 platform, we're putting a ton of GPUs right next to each other. And why do we do that? Is it because we like fireballs? No, it's we do that because copper where you can. Copper, as we get faster and faster links, 400 gig, 800 gig, 1.6 terabits right around the corner, those copper links get shorter and shorter and shorter. So we need to squeeze and put the GPUs closer and closer together. And that's what's driven us to actually the liquid cooling. And there's a ton of implications of liquid cooling for the data center, for the chassis. All of that is really new infrastructure that's being invented and built as we speak. We're finally driving this now out into the market, so we're really excited. And then at the other end, with low power devices, you know, we can't put those, you can't have liquid cooling in a small robot or in a small device somewhere. So we have to optimize for power with our Jetson Thor, for example. Yeah. So we really have the full spectrum, but power is always a challenge.
I mean, the other thing that I actually didn't mention that's obviously impacting that ability to move the stuff to the edge is how smart the models have been able to get and shrink, right? We've been able to shrink the model significantly. Memory footprint's a huge concern, all those kinds of things. But yeah, there's a lot of very cool dynamics. How about you, Adam? You got your magic wand. How do you make AI go faster or, you know, more applicable?
If I had a magic wand, I would make Moore's law never slow down. Actually, the industry is doing a great job at dealing with that. But maybe on a more specific note, actually, one of the biggest constraints I think the industry is facing is simple human talent. There's a bit of a shortage of really great, silicon design engineers and semiconductor professionals across all functions. And, it's a first-class problem to have in that we have to, have the tough decision of figuring out which projects or products we go after or don't. But ultimately, it's a limiter for what our mission is, which is to make technology available in volume to everyone in the world. And so I don't have any easy answers, but for the kids watching at home, go ahead and get that double-D degree. We need you, please. And then the other thing I think is partnerships. If companies can work closer together and find those complementary projects, we can get things done that we couldn't otherwise.
That's really cool. That's cool. Unfortunately, none of my kids followed to get an electrical engineering degree. I think they didn't like dad travel too much or something. I don't know. All right, cool. Well, we've got an amazing audience here. And so, I'd love to hear, Kevin, what's the thing that you would like to leave this audience with? We've got developers, we've got partners, we've got, all kinds of ecosystem players here. What would be the message you'd want people to think about as they head into COMPUTEX day one?
Yeah, I think the key is that AI is not your father's software. It really is a sea change in terms of these new models, the way that AI works with agentic AI. Software in the past has been a tool, and you would ask it questions, and you would often tell it how to solve the problem. And I think everyone in the audience here should start thinking about AI in a different way, where you engage with it as you would a partner or a coworker. So instead of, simply asking it a question, AI can be introspective. You can ask AI, what questions should I ask? How should I solve that problem? Help me think about this. So talk to your AI. It's the kind of thing that, for those of us who've been around for a while, we don't typically do. You ask an Excel spreadsheet to give you an answer. AI is very, very different. And so I think that the most effective use of AI is when you start to think about it more like a coworker or a collaborator, and you engage with it really on a deeper level than you would with traditional software.
That's super insightful, Kevin. Sam Altman, I think, recently stated or tweeted about, how older folks like ourselves here, we kind of use ChatGPT as a search engine, but the younger generation, and I definitely see it in my young adult kids, they're using it as a life advisor, like you're saying, hey, what should I do? What should I think about it? It's definitely pretty amazing the way that AI is going to be impacting the next generation and generations beyond. Mm-hmm. How about you, Adam? What's the message for this audience?
Well, I'll preface it with, I'll declare myself as a techno-optimist. I think AI has the power to really elevate humanity and help everyone be more productive, be more fulfilled in life, to be more economically resilient. The challenge is getting that technology into the hands of everyone on the planet. So I guess my message to all the great partners and customers and collaborators and developers in Taiwan and elsewhere is let's work together to make that happen.
That's a great message. And the democratization of AI is a personal one for me. And just as I think about, obviously the penetration of smartphones into so many groups across the planet. And now if we're able to give them access to experts, right? Mm-hmm. If you think about what that could mean for education, what that could mean for economies, to be able to have an expert in your hand, whereas you may not have even been able to go to university before, and now you've got this expert self-driven. I think we've kind of seen, again, back to the different generations, what YouTube's done and how people learn anything on YouTube, or they can. And now this just kind of 10x's that, or if not more.
We used to have to go to the library and look things up in books.
Or how about encyclopedias, the 26 encyclopedias. So, yeah, so anyway, so I really appreciate Kevin, you and Adam being here today. I want to appreciate all of you, so many important partners here from the ARM ecosystem. It is absolutely our pleasure to be here. Thank you for your partnership. We could not be more excited about the opportunity that's ahead of ARM, but that means an opportunity ahead of all of you. And really look forward to having a great week, and thanks you all for coming.